Our project is called Dinestination. It's an Android application developed as a course project for UC Berkeley's CS160 Spring 2018. The motivation behind this application is to address a problem that almost any mobile device user can relate with. When on your way to a destination under a time constraint, it is difficult to find a place to eat that will get you to your target location on time. This process of finding a route-friendly place to eat currently involves a fragmented workflow across many apps and queries. We're targeting people who have a place to be at by a specific time and need to get something to eat along the way. Based on user testing, we found that the average user faced with the aforementioned task will likely use some combination of Yelp searching, Googling, opening navigation apps, and more to realize their goal. This manual searching is inherently a limiting factor in both efficiency and range of discoverable restaurants. Users will likely manually search for restaurants only around their start and end locations, thus missing out on many options along the route. This behavior is nonetheless understandable given the nature of the current available workflow. A balancing act across apps requires mentally keeping track of a lot of information if you want to find a good place to eat that won't make you late. These users are operating under time and locationing restrictions, rendering the nonlinearity of the current workflow far too inefficient in the desired use case. We thus took on the task of integrating the process of finding a place to eat into a linear and easily adaptable flow. Our solution creates a single flow for finding a place to eat that won't make you late. Dinestination abstracts away the current search process. By simply entering the destination you're headed to and the time you need to be there, our app suggests restaurants to eat at along the way that will get you to your destination on time. We realize this goal by running an algorithm on data queried from Yelp, Google Places, and Mapbox APIs. Customizability is also seamlessly integrated into the workflow for users who want to filter the types of restaurants suggested.
Oh, what a nice day in San Francisco.
Yeah, great day for a concert.
Hold up, guys. We do have a concert.
Oh
in
no!
2 hours!
Oh wow, I'm so hungry right now.
Same, we've been walking around all day.
Let's grab something to eat then.
I'm feeling Italian.
I was thinking we could try Burmese.
Let's try to make it not too expensive, shall we?
Yeah, somewhere casual would be nice.
How will we solve this dilemma? Our concert's only in 2 hours.
Hey guys, look at this app I have. It's perfect for this problem.
Whoa.
Imagine you're with a group of friends in Berkeley and you're on your way to a concert at the Fillmore and you have to be there by 9 p.m. but you want to grab something to eat along the way. You can input the destination you're going to, as well as add some filters for what type of cuisine you're interested in and the price range, etc. Set the time that you need to be there by, and then search. You can toggle between different modes of transportation and the correct route will show up accordingly. But let's say you're driving. So after selecting driving, you click the Find Restaurants button, and restaurants pop up along the route. Restaurants that are more opaque get you there faster. After checking out a few of the different options suggested by the algorithm, you decide on a restaurant, look at the wait times, everything looks good, and you can get there by turn navigation.
Wow, what an amazing app.
It solves all of our problems.
We found a place to eat,
And it's on the way.
According to all of our preferences.
and we could get to our concert on time.
Wow!
We integrated 3 different external APIs into a single process. Doing so involved jumping over hurdles such as cascading asynchronous calls and runtime optimization. We broke the generated Mapbox route into intersections and assigned radii to each point, the number and density of which is dynamically determined based on the amount of time the user has to get to their destination. We then run a Yelp query on each of these regions with the user's inputted filters passed to the query. Our architecture also used Google Places for auto-completing, geocoding, restaurant feature information, and more. User testing informed many of our decisions as we transitioned from prototype to final product. Based on user feedback, we decided to add a scrollable bar of the filters applied to the top of the interface. We also changed the way that we assigned visual prominence to the displayed restaurants. Initially, we were using a gradient to assign priority, but transitioned to assigning better pinpoints a higher opacity. If we continued this project, we would perform more rounds of user testing to gather more information about how best to assign visual priority to the returned restaurants. We would also continue to refine our existing algorithm.